Assalamualaikum warahmatullahi wabarakatuh. For our assignment, we are presenting about the ECM process or the electromachining process. Our group members consist of Amir Mirza, Muhammad Amirul, Muhammad Hadif, which is me, Muhammad Faizul Iqbal. For the introduction, the ECM process is a process that removes the metal from the workpiece by following the concept of the Faraday's law of electrolysis. It is the reverse process for electroplating, where electroplating it adds metal to the workpiece, and the ECM process removes the metal. The working principle for this process is that it is anode and cathode will be submerged under the electrolyte solution. The anode will be positive and the cathode will be negative, and the anode will be the workpiece and the cathode will be the tool. Positive ions will be attracted to the cathode and the negative will be attracted to the anode. This is the example of a reaction when the voltage is applied and the reaction at the anode and cathode, and lastly the reaction within the electrolyte. Thank you, that's all from me.
For the best setup of electrochemical machining equipment, we have 4 systems. For the first system, we are using power supply, which is DC power supply. And then next, the workpiece and work holding system. For the workpiece, mostly we are using brass, copper and bronze. Third, tool and tool fit system. Commonly, the tools are made from anti-corrosive material. And then lastly is electro-type supply and cleaning system that include of piping system, storage tank, pressure gauge and also pump.
Assalamualaikum warahmatullahi wabarakatuh. Now I will present about application of ECM process. First, we got roughly barrel. Roughly barrel means that my wet actually the inside of a barrel, while it is being electrical charge, roughly is scattered without the need for normal metal machining. So to make the grooves of the barrel, the metal within is really eaten away or dissolved. After acetic and electrode with metal strip, the entire assembly will be immersed in salt solution. And then the material will be pushed along the barrel's length and turn. Okay, next we got multiple hole drilling. For multiple hole drilling, it is like a development above standard drilling procedures with fixed machining patterns, such as the multiple hole drilling operation. Even though the daily operation are carried out from one hole to the next, picking and choosing the right drilling operation holds down execute faster thanks to the machining patterns for multiple hole drilling. So this operation can be used on a certain work unit such as making truck engines, and each comes with several spindles. So next process is deburring. Deburring is the process of eliminating the burrs or tiny flaws from items made of machine metal. Different machining techniques can mold a piece of metal. For instance, in stamping, the workpiece is pressed into a die set, but immediately metal is removed from the workpiece using a spinning tool. The after deburring process, the product will have a smooth, dependent work product, such as smooth surface or smooth edge. Uh, the very frequently made of polyamide fibers covered in a coarse abrasive. The last one is 3D profiling. 3D profiling involves cutting three-dimensional shapes on non-flat material, and the range of the geometries that can be cut using a plasma 3D profiling machine as a really wide range of geometries, such as hexagonal tubes, beams, channels, and oval pipes. Yeah, that's all for me. Thank you.
We are moving to the application that affect the process parameter. So for the first effect of the process parameter is concentration of electrotype. A concentrated electrotype capable of flowing with a low resistance to the machining current. Then the metal can be removed under the limit. And the disadvantage is that salt crystallizes out of the solution at higher concentration and the closed area is as in the machine enclosure. Temperature. By referring to the graph, we can see that the surface roughness becomes poor due to the increasing temperature, and also the electrotype temperature is higher than 50 Celsius and the quality of the surface deteriorates. And during the increase of the temperature of the electrotype, the specific resistance is also decreased, and this can affect the flow rate and the pressure of the characteristic of the electrotype. And voltage. As we can see that when the voltage is increased, the surface roughness become decreased. And also, you can see that the surface roughness is in good condition when the voltage rise above 30 volt. And we can improve the surface roughness by increasing the voltage at a range of 30 until 40 voltage. The duty cycle. During the condition of a low duty cycle, the processing time is very low, and this can be enough time for the removal of the electrolytic product. And at a duty cycle of 0.3, by referring to the graph, we can see that the surface roughness have a good surface roughness.
Hello, so I'm going to present about summary about this ECM process. Okay, so the first is performance, advance and limitation. So for the performance, the anode and cathode as well as surrounding electrolyte fluid all the participate in the electromechanical reaction. Ion flow between the tool and workpiece as the electrode is subject to an electrical current. So positive ion move in the direction in the tool in electrochemical machining, while negative ion move in the direction of the workpiece. Okay, first we have advantage. This is the list of the advantage of ECM process. First, little to no heat produced, absent tool wear, negligible stress on tool and workpiece, great surface finish, accurate dimension, and lastly we have able to conduct mass production. And lastly we have limitation. This is the list of limitation in the process. Okay, first require a large area, and second is very high in initial cost and maintenance. Metal in the process have a higher chance of corrosion, and only good conduct metal can be machined. And lastly we have very harmful to the environment for the limitation of process ECM process.